Yes, we are.
Hello, everyone. Good afternoon, teachers and dear students. I welcome you all back to the Sparkle Study session brought to you by Vigyan Jyoti program. After quite a long break, I hope you all rocked your term examinations. Teachers, please ensure that you're on mute. Thank you. Okay, so yeah, so I hope all the students had rocked their examinations. So today's session is on the topic electrochemistry, which will be led by Dr. Srisha Bhatt. You all might have already met him once in the first session of the Sparkle series. He is the head of the chemistry content team in CCL and is involved in creating engaging and fun chemistry activities, meanwhile also focusing on inquiry-based learning. And Dr. Srisha holds a PhD in chemistry from the University of Lincoln, UK. So without taking any further time, let's begin with the session. Over to you, IIT Gandhinagar team.
Thank you. Thank you, Justy. Hello, everyone. I have kept the option to unmute yourself. So anytime you feel like you have any question, you can just raise your hand and unmute yourself and ask anything, or we will even make the session more engaging in terms, we will try to make it interactive, and we will try to interact with you. Has everyone got the requirements for the activities? If everyone can, on their cameras, that would be great. If I could see everyone. So can anyone mention in the chat or just unmute themselves and say if all the classes have the requirements for the activities? People can't hear my voice, is it? Can everyone hear my voice?
Yes, Risha, it's audible.
Okay, some comments. Okay, so JNV Champavat says they have. So the requirements which were given was for making a battery. So today's session is about electrochemistry, and we will be going through some of the stories of how the first battery was invented, and we will also try to make a battery ourselves, and then go more deeper into the how a battery is made, or what battery consists of, and what are the different kinds of batteries, right, which are available, and what research is going on in the field of batteries, and how and why they're important. So we'll be doing that, but just before that, I would like to see. I would like you to raise your hands if you have the materials with you. Then I can know if, okay, Gatshui Roli says they have. Great. Excellent. Any other school? Yeah, I don't see many cameras on, so. Okay, JNV Ajmer says they have. Srushti. Okay.
JNV East Godavari one also.
Okay. Yes, okay. I will just give it co-host. Sorry, I had to. We have another camera arranged for one of the demonstrations, so just giving them the rights. Okay, so let's start. I will share my screen, and we will just jump into the world of electrochemistry. So is everyone excited? Yeah. Okay, cool. So let us start first with the first activity which we are going to do today is making a battery out of coins using just day-to-day materials, using a 5 rupee coin and silver foil. Sorry, the aluminum foil, not the silver foil. So if you can see the slides, I hope you're able to see. Okay. Hands up if you are able to see the slides. Great. Champavat, Kadichori. Okay. Okay. So we start with one of the interesting stories, so which I find very fascinating. There was a scientist called Luigi Galvani, and he was the scientist in Italy who was studying some anatomy of some frogs and animals, and he would, like dissect the frogs. And he saw that there was a so during that time in 1780s, there was not a source of electricity. So there were just two things which they knew was static electricity. So everyone knows about static electricity. Can raise a hand. Static electricity. Yeah. Someone is raising the hands. Static electricity. Any idea? Okay. Anyone from? Okay. So there used to be.
We have JNB Ajmer who had raised their hand. One of the students can come in front, maybe unmute themselves and speak if you want.
Yeah.
From JNB Ajmer.
Ajmer. Okay.
Yeah.
Okay, JNV Ajmer.
Okay, I think one of the students is coming.
Okay.
When current is at rest.
Sorry, current?
Is at rest.
Okay. So how do you know how static electricity? Do you know any examples of static electricity?
Example.
When Silk Road is rubbed with hairs, then there is movement of charges from positive to negative.
Right. So you must have rubbed some rod on your hair, and if you then put it on your hair or on your hand, you would see it raising, right? So there is some charges there. So very, very nice, JNV Ajmer. And can I know the good name of the person, the student who answered? Yeah, you can unmute yourself.
Sir, Suman Jat.
Suman?
Yes, sir.
Okay. Nice. Very nice answer. And I expect everyone to be participative today. So I would be very happy to interact with you all. Okay. So that time there was no continuous source of electricity like you have today. So it was mostly some static electricity or some electric lightning which you see in the sky. So when Luigi Galvani was dissecting the frog, he saw that the dead frog, the legs twitched, and he was really surprised. So he thought, okay, maybe it is due to some electricity like lightning, or is it due to the static electricity machine? He couldn't understand. So he then went to a different room, and where there was no static electricity machine, and he then suspended the legs of the frog on brass hooks, and he was just probing that with the metal. And he saw that still there was some twitching, and to see if So he saw that static electricity machine has nothing to do with this, because he was just doing this in a separate room. And also to rule out the lightning, that lightning is responsible, because he also thought, okay, if that is responsible. So he again took the frog legs and then, attached it to the gates with a hook. And lightning was happening. Lighting was not happening actually, but still the frog legs were touching. So again, to rule out the two factors which were there, static electricity or lightning, he did these experiments, and he said, okay, maybe this is something to do with the animal. And he said that the animal inside, whether the muscle and the nerves are present, so there is some electricity which is generating, and he called it animal electricity. So I have some very interesting video, I think I will show. So if you can see, so this is a representation of what he would have done. So he has taken this frog leg, which is not alive, and then they will put some, so if you see, they will connect the muscle to the nerves of the frog. So I don't know if you can see. So once he's connecting this, you will see that frog leg is twitching. So that is what he would have seen during his time. And what he did is he called this animal electricity. And during those days, he published this paper as well. So there is a 1791 paper where he published his results, and he says that animal is responsible, that the animal tissue is responsible for generating this electricity. But around the same time, in 1794, Alessandro Volta, another Italian scientist, he was like, I don't think this is the frog which is generating the electricity or the animal. And he's like, frog legs are only conductors, and electricity is, because if you see where he did this experiments, he used two different metals. The one was brass, and another was either an iron. So he used two different metals, and along with the frog. And Volta was like, it is because these are two different metals, and that is responsible for generating this electricity. So what he did, he replaced the frog. So he said frog is a medium, and what he did is replaced the frog, and he just took some cardboard sheets or a cloth and dipped in some salt water. And he took two different metals, and he then showed that, this is also generating some electricity. So it's not the animal which is the main reason, it is the two different metals which are present there. So what he did is he took discs of two metals, and then he went on to pile this with a cardboard sheet in between, and we call it the voltaic pile. And this was the first continuous battery, the first continuous source of electricity. So the first battery which was invented. So what we're going to do today is to try to make Volta's first battery. So there he took two different metals, which was, if you can see here, silver and zinc, and a cardboard sheet in between. So if you can see, this is one metal, this is another, and in between there is some salty paper. So one is zinc, one is silver. So today what we're going to do is we're going to use a 5 rupee coin, which is, if anyone knows what 5 rupee coin is made up of, which metals? Any guesses? No? Okay. So 5 rupee coin is usually an alloy. Alloy is usually a mixture of metals. So it has some copper, nickel, and zinc, I think. So it has majorly copper, nickel, and some of the other metals. So we have one copper coin, which is a like 5 rupee coin, which is a mixture of these metals. And another we have taken is aluminium foil. So aluminium as a metal, and the 5 rupee coin is another metal. And what we are going to do is we are going to have some cardboard sheets, which will be used as a medium. Which will be dipping in some salt water or lemon juice or vinegar. Okay, so let's start with this activity. So if you have everything with you, please, have it with you, and we're going to do this activity very quickly. Okay, so everyone has 5 rupee coins. I have made battery with these 5 rupee coins so many times. Yeah, you can see what halat uski kharab ho gayi hai. And then you have some cardboard. You have some aluminium foil with you, and one cardboard piece. Okay, I can see JNV Ajmer. They're showing they have it. So let's do it together. So what we're going to do is we are going to take this 5 rupee coin, and then I want you to. So what we want is we want to cut these in the shape of these coins, both the foil and the cardboard sheet. So please have some scissors with you, and some pen or pencil. And what you're going to do is you're just going to draw this coin over the cardboard. Okay, so around we should have around, let's say, five to six. Okay. So if everyone can draw this and then cut it. Similarly, what you do is you take aluminium foil and then you fold it a few times, so that you need to cut it only once. And then again, you put this and draw on top of it. Let's say we draw 2. Okay, so you can just cut it along where you drew it. Okay, so you have 2 metals and this cardboard in between. So I already have a few. I have already cut a few of these pieces. Similarly, you take this and then you cut it. Okay, so in one cut, I think you will have many of these. Okay, and then what you have? Do you have some salt solution or some vinegar or something? So I have some. I think I have some vinegar with me.
Vinegar.
Yeah.
Salt.
Salt solution. So I have both salt solution and vinegar. So you can take either of these, salt solution or vinegar. So is everyone else doing this, or I can see East Godavari doing. Okay. Fine. So please raise your hand if you're done. Okay, so you have around 5 coins, right? You have 5 coins, and you take some 5 of these cardboards, discs, and you have these aluminium foil discs. So you have these 3 things, and some of the vinegar or the salt solution. So what I will do is I will just dip this in salt solution. So after that, you just need to dip these in the salt solution. Okay, so I will just think. So how is it going, everyone? It's going all right? Yeah, I can see Gadi Gachiroli, they are doing some cutting. Okay, meanwhile, you guys are doing it. I will, I think, just show what we are going to do. So meanwhile you're doing it. So for the others, I have an interesting, I think. So what used to happen is while Volta was doing this, right? So here is a clip wherein you could see what Volta did actually. So he took these cardboard sheets and then he dipped in some salt solution. And then he had this kind of a setup where he took two metals. So one was zinc, one was I think silver or copper. So one was zinc and another was copper. And then he went on to make this pile. So this is how the pile would look. And so this is a video where they're trying to replicate. And you see, we have some LEDs right with us to test if it is generating some, electricity. But what would Volta do? So he would take his hand and he would dip it in a salt solution, other hand on top of the pile. And the lower, metal is dipped in the water, and you would get these shocks. And so that is how he would test his battery, that is it generating some electricity through these sparks. And he used to test it with his all this with tongue, using his own saliva as a conductor. And he would also test it like just putting this his hands on top of the pile and one hand in the water, and he would get these shocks. And by getting these shocks, he would then judge what is the capacity of these different metal batteries he would make. And he went on to test different metals. So first, the Voltaic pile, he took silver and copper, but then he went on to test different metals combinations, and then he would see these sparks and the shocks, and based on the shocks, he had generated his own electrochemical series. So everyone is aware about electrochemical series. If anyone can unmute themselves and tell what an electrochemical series is and what does it say about different metals, and how the arrangement is and why the arrangement is. Just anything. If anyone has come across this in their studies. Anyone?
Electrochemical series, also refers to as an activity series, is a list that describes the arrangement of the element in the order of their increasing electrode potential values.
Right. Who was this? I couldn't see. Yeah. So based on the potential, so you usually have reduction potentials, right, of different metals. And based on that, there is an order which is there, and those has been done very recently. But at that time, Volta, he didn't have anything, and he had made his own series, which is very similar to what is you have currently. And in the current series, you have a potential as compared to the hydrogen, right? You have hydrogen as a reference electrodes, and you compare the potential in reference to the hydrogen, and you have these values. And Volta did what Volta did was so I can show you the series. So this is the electrochemical series, right? So this is in reference to the hydrogen, right? And you have these metals, and he had published this electrochemical series just by using his experience of the spark, of the shocks he would get using different metals, and it was like really accurate to an extent. So let's move to back to the activity. So has everyone, whoever is doing the activity, been able to cut all these things, all the three things? Yeah, if JNV Ajmer. Okay, I think you can. Okay, some cutting is happening. Some classes don't have, I think, the coins. It's all right. I will show the demonstration. That's fine. Okay, everyone done? So I will just go on. So what you need to do is, yes. So I can see some hands up. Okay, so you're going to take this coin. Okay, you take one coin, and what you're going to do is you remove.
Hi, Srisha, sorry to interrupt.
Yeah.
Can the PPT be closed?
Oh yeah, sorry.
Yeah.
Oh, thank you. Yeah. So you take the coin, right, and you need to take this cardboard from the solution, whatever solution you're using, salt or vinegar. You just dab it off a little bit, and then you place it on top of this coin, and then you take this aluminium foil on top of this. So this what you have is one cell of a battery. So wherein you have two metals sandwiched. So these are the two metals sandwiched in between one cardboard sheet, which is your electrolyte, basically what you have dipped it in. Okay, so this is one cell. So if you have LEDs with you, you can test if this lights the LED. So the longer leg in the copper and the shorter leg on the top. But we see that it's not working. So that means it has not enough potential to light it. So I also have a multimeter with me, so we can check how much of the voltage it is generated. So I'll take it here. So if you can see, it is around 0.6. And usually the LEDs which we have, they you need around 2 volt or 1.5, more than 1.5 volt to make it light. So we need more cells. So if you see a battery, you see that they are connected in series, or maybe you have made some batteries like a Daniel cell, it's connected in series. So similarly, you need to have more cells in series to generate more potential. So again, what you do is, on top of this foil, you put one coin, and then this cardboard, and then a foil. So this is 2 cell. Now I take another coin, one cardboard, and then this foil. So the order is coin, cardboard, foil, and then you have to connect it, right? So you need to have another coin on top of it. So coin, cardboard, foil. Again a coin, A cardboard dipped in electrolyte. And foil. Okay. So now I have around, you see, 1, 2, 3, 4. 4 cells. And let's check what voltage do we get. So we are getting around 0.7, 1.73. Let's check if this lights our LED. Okay, we have one more. No, I think we need maybe one more of this. So I will take one more coin. So how many cells have you added till now? So I've added 5. Okay, I've added 5 cells. Let's check. It close. Anyone did any LED jala kya? Hmm? Yes, किसी का LED जला? Okay. So do we have any results yet? So one important thing to see is that you have cut it right to the size. Because what happens is, like if you see here, so there are some sheets which might touch the coins. So then what would happen is it will short circuit the battery and you won't find it is working. So we need to see if the size is correct. So any difficulties, or is it working? Is it not? You can unmute yourself and let us know. So make sure that the foil size is not very large. Otherwise, you will find that it's not working. Okay, so let me see. So let me see the voltage for this. So now I can see it is more than 2 volt. Right? So let's see if this works. For some reason, my I think now I can see. I don't know if you can see. Let me switch off the lights. Yeah,
Yes, it's working.
it's working.
Yes, sir.
Yeah. Okay. Great. If it's working for anyone else.
ठीक है अब वो बहुत कम लाइट
Yeah, we can switch on the light.
बस ठीक है
It is.
ऐसे ही रख जैसे हुआ था
We can switch on the light. Is it? हो रहा है क्या? हाँ, जल रहा है. Gadchiroli, I can see red LED. Great. What about others? Ajmer, आपका चल रहा है क्या? So the thing is, so first I was trying, and there were a lot of problem in the sense that I could see. जैसे ये है फाइल में आप देखोगे आप जब भी बनाए और भी लोग, so you make sure that the aluminium foil is not touching the other coin. Otherwise, what would happen is it would stop. It wouldn't work. It would just short circuit. So you need to make sure that all the cuts, whatever you cut is same size as the coin, so that you don't have this. So finally, we have the LED, which was glowing, and which was this is an example of the first battery, which was made by Volta, and he did a lot of experiments on this. Okay, should I wait for others? Ajmer, what any difficulty you're having? You can unmute yourself and then let us know. Okay, I think these are some of the few things you need to keep in mind. Should I go ahead? Yeah, I think you can try this, and let me know if you have any difficulty. You can let me know now, or we can do this later. JNV, Ajmer. Okay, I think they're trying. They're trying. Okay, cool. I think we have less time, so I need to show many more things. So I will just move ahead. So what is happening is in our case, so there are two electrodes, right? So I will just share my screen. So what we have is a coin and a foil, which are two electrodes, and what is happening is the aluminium foil. So if you see the series, you will see the aluminium is higher up on the series, so it has a more tendency to donate electrons as compared to copper. So what it would do is, so this difference in the reduction potential would lead to the aluminium donating its electrons, and this was the case of Alta. So I will just move on to our case. So aluminium at one of the electrodes. So I'm sure you must be familiar with electrodes and electrolytes. So these are the two electrodes which we have, and at the anode, which is the aluminium foil, aluminium is releasing the electrons, and you get Al3 plus 3 electrons. Okay, and what would happen is, so if you see this, I don't know if it is working. Yeah, So if you see this, you see that there is a negative. If any battery you see, that is, you see minus and plus signs, right? So here, aluminium is where the minus is, which is the anode, and the plus is where the cathode is, which would be our copper coin. Okay. So these are the two electrodes, and you see the electrons, which is flowing from here and which is leading to the LED glowing. So electrons is traveling from here, which is released by the aluminium, and it passes through this LED and is accepted. These electrons are accepted at the cathode, which is the positive electrode. So these are the two electrodes which we have, and an electrolyte. Right, electrolyte is you either take salt water, you take vinegar, because there are some ions in this, right? Ions in the electrolytes, which is letting this reaction or the electrons to, which is aiding in the electrons to flow. So we have some questions like, what is the role of the electrolyte, right? So what if we don't take this electrolyte and we just, let's say, we make a pile with dry cardboard? Would you think this LED would glow? Anyone? Yes or no? So you can, if yes, then you can raise your hands. If no, then you can show some other sign. No, just shake your heads. Anyone? If it is dry and if you don't take any electrolyte, would this LED glow, or would there be an electricity, I mean, generation? No? Okay, I will help you in this. So electrolyte, if you don't have an electrolyte, you won't have the aluminium, dissolving in the electrolyte, and you need your metal to dissociate. And for that, you need the electrolytes, and you also need electrolytes so that there is a conduction of electrons in the outer circuit as well as in the inner circuit. What other electrolytes you can use is basically salt water, lemon water. You can also use cold drink. You can use anything which has some ions in it. And another question is, when will the battery stop working? So from this, we could see that it would stop working either when your electrolyte goes dry, or one of your electrodes is consumed. And whoever does this, I want you to keep this pile and then see if you find any difference in the pile. If you see any changes on the surface of the metals. Okay, and what are the reactions which are happening at both the electrodes? So one I showed. So in case of Volta, you had the zinc and copper. So probably the zinc, which is higher in the series, it is donating its electrons. But what is the reaction which is happening at cathode? So which is a very interesting question, and a lot of people have tried to answer this. So a lot of people have tried to answer this, and mostly people used to think that it is the H plus ions. So it is not the metal which is participating, right? So the coin is acting as an inert electrode. So it is not participating. Like you see in those Daniel cell, right? You see that, okay, copper, you have zinc, which is donating the electrons, and then copper, which is accepting the electrons. But in here, there is no copper sulfate solution. There are no Cu2 plus ions. It is copper metal. So it is not participating in this, it is not participating in this reaction, but it is just acting as an inert electrode. And what people used to think is that it is the H plus. So usually you have electrolyte in water, right? NaCl in water or vinegar, you have a positive H plus ions. And H plus ions is the one which is accepting these electrons, which are which this metal is donating, and you get a hydrogen gas. But there has been, this was done 200 years ago, and still people are not sure what is happening. And there was a paper recently in 2021 where they said that no, it's not just the hydrogen, not just the H plus ions in the electrolyte, but the oxygen. Which is from the air, which is getting dissolved in your electrolyte, and the other metal is just providing the surface for the oxygen to accept these electrons. And what they did is, if you can see the image, so they put one candle, and then they have this voltaic pile here, and they are checking the potential constantly. And they saw that because candle is burning, and because candle is burning, there is some oxygen which is consumed, right? It is a combustion reaction, and you see that there is a decrease of oxygen in that jar, and you see the voltage, the potential going down. And as soon as you again expose it to the air, it comes back. So it is a really interesting experiment, and still people are trying to figure out the mechanism of how these batteries, or the world's first battery which was made, is working. So they said that it is a combination of this oxygen, oxygen reduction. You would say reduction because it is consuming electrons. So oxygen is consuming electrons, and it is getting reduced, and you have some OH minus ions. So this is the reaction which is happening, which is oxygen accepting these electrons and making these hydroxyl ions. Okay. So this was the first battery. So we have many more batteries. I think we took a lot of time in making the battery. So we move on to the next one, which is an electrochemical cell. So electrochemical cell is something wherein we will see, where we saw now the electrode potential between these two metals. But what if we want to see for different metals? So we have this very interesting setup. So I will just get this here. Stop share, and then share this. Okay. So what I will do is I will remove these things, and I have this very interesting setup where I have just taken, let's say, a filter paper, and then what I've done is I have cut it into these shapes. So probably if you just take this and like see. So you have something like this, and if you can, you just cut it like this. Yeah. So probably, so mostly you need to cut it in this shape, wherein you have 4 of these, it's like a flower shape, and you have a cut like this. Okay. So today I have Nisha ji with me, who is assisting me, and she will. You just cut it this way. Yeah, great. And then when you open it, you have this kind of setup. Okay. So we have here 4 metals. So I want you to note down. So I will just quickly share my screen. Okay. So this is, so I want you to quickly note down this half cell combination. And we will note down what values we get of the potential difference of this. So we have basically 4 metals: iron, zinc, magnesium, and copper. And what we're going to do is we're going to drop a solution of its salt. So iron sulfate, magnesium sulfate, copper sulfate, and zinc sulfate. And then some potassium nitrate in between. And then we are going to measure the potential difference between these metals. And what we're going to do is we're going to make our own electrochemical series based on these. Okay. So if you can note down, or whenever I say, you just have it with you, whatever potential difference we will be noting down. Okay. Okay. So here I have the multimeter with me. And what I'm going to do is I'm going to put the corresponding salt solutions here. So magnesium sulfate. So I have some magnesium sulfate, which you're going to just put on top of magnesium. Fine. And then I have some, what is this? Zinc. So I have some zinc sulfate, which I'm going to just put it here. Then I have some iron. So I need some iron sulfate. I'll just put some ferrous sulfate on this. Okay. And then I have some copper, which is here. I'm going to drop some copper sulfate on top of this. Okay, so we have 4 metals and 4 solution corresponding salt solutions. And then I have some KNO3, potassium nitrate. So I want you to recall why, if you have seen any battery which is being made and then there is some potassium nitrate they're adding in between or something. So I want you to recall that. Meanwhile, we just start with this. Okay, so first we have copper and magnesium. Page so we're going to write down the values. Okay. I can have another page. So I also want you to write the values which we get. Okay. So first let's take copper and magnesium. And I will have one electrode here and one electrode here. So we are seeing it's minus 1.63. Okay, I will just change it so that we get a positive value. And okay, so we have 1.62 between magnesium and copper. Okay, and because we are seeing it's positive 1.62. Okay, this is the potential difference. Okay, next what we will do is we will take magnesium and iron. Oh, sorry, this is zinc, sorry. So this is magnesium and zinc, and we are getting around 0.6. So magnesium and zinc, which is 0.6. Then we take magnesium and some iron. So this is the iron, and we get around 0.92. Magnesium, iron 0.92. And then we have finally magnesium and copper, which is around 1.5756. 1.56. Okay, so as we are seeing that this is a positive value, and whenever we are keeping this electrode on the magnesium and the others on the other metals, we see there is some positive value which is coming, and that is a potential difference. And you see it is very high for magnesium and this we have already done, right? Yeah, so this we have already done, which is the same as last, magnesium and copper. So that is, you see 1.62, and we have, if you notice, I kept the same electrode on magnesium and we are getting all positive values, right? So we can say that the difference between magnesium, so magnesium and everyone else, we see there is a lot of difference. So can we say that magnesium potential difference is greater than copper? Magnesium is greater than zinc. Magnesium is greater than iron. Okay, now let's see if we take zinc and iron. So we know that now magnesium would be on the top. Now let's see what others. So if you see the difference between magnesium and iron, and magnesium and zinc is very less. So maybe we can say zinc, and then we see iron, and then we see copper. But we will verify it again. We will try to see zinc and other metals, zinc and iron. Let's check zinc and iron. So again, I will be putting zinc here with the black electrode, and zinc and iron. Yeah. So we see it's 0.3. So this is 0.3. Again, you can get this if you minus 0.92 minus 0.6, because here you had these two metals, right? Magnesium with zinc and iron. And if you are subtracting this with this, you get this value. So you see again that zinc is the one. So everywhere you see magnesium and copper, we have attached this positive electrode on that, and you see the flow, how it would be, because it's positive here. So magnesium is the one which will be donating the electrons, and copper will be the one which is accepting the electrons. So similarly here, magnesium is the one which is donating the electrons. So we saw in the series, right? Higher the metal in the series, the more readily it donates its electrons. So it will donate its electrons very readily. So what we are saying is here, magnesium and copper, and magnesium and zinc, magnesium and iron. So we get all these positive values. That means magnesium is the one which is readily donating electrons. That's why we could keep magnesium at the top. Okay. Is everyone following? Is anyone finding it too difficult or confusing? Please raise your hands and let us know. But I want you to come up with your own electrochemical series through experimental way rather than we are just saying on the textbooks, right? And we saw zinc and iron again. So zinc is the one which is donating the electrons because we're getting a positive value. And so this is definitely the case where zinc is higher than iron. And if we see iron and copper, let's say I put iron here and copper here, again we are seeing a positive value of 0.6. So again, which is something 1.62 minus 0.92, which is around 0.7, which you're getting. So iron and copper, you're getting around 0.6. So here, this way, this is a very easy way to do this, where you experimentally derive your own electrochemical series and see which is coming on the top and according to its reduction potential. So reduction potential is something where it is readily able to reduce something, and if it wants to reduce something, that means it's donating its own electrons. It is oxidizing itself. So all this electrochemical reactions is mostly two terms, right? Have you heard about redox reactions? Anyone? If anyone can unmute themselves and tell something about redox reactions. So what is redox? It is reduction and
Yeah.
Yes. Yes, someone wanted to say.
Where oxidation and reduction take place simultaneously.
Right. So oxidation and reduction is taking place simultaneously. So all these reactions, we are seeing that something is accepting the electrons and another participant is accepting these electrons. One is donating and one is accepting. So one where you are donating the electrons is oxidation, and one where you are accepting the electrons is reduction. So there is a very popular acronym, which is OIL-RIC. So which is oxygen is loss of electrons. So they say oxygen is loss of electrons and reduction is gain of electrons. So here you're seeing that the two metals, based on the reduction potential, one is donating the electrons and one is accepting the electrons. And this is a very nice way to see for ourselves the electrode potential of the metals. So now we saw that now we saw that you have these two different metals, and which is generating this potential difference, right? Based on their ability to lose electrons, there is a generation of an EMF. You call it electromotive force. So electromotive force, we have seen that it is generating because of this potential difference between these two metals. But is it really? And we are seeing that there is some voltage generation we saw through our multimeter. So there are different potential generation. There is voltage we see it is generating. But can we use just one metal and generate a potential difference? Because till now we are seeing what Vata said, that you need two different metals. And this potential difference between these two metals is what driving this reactions and generating electricity, because that is causing the flow of electrons. But can we say that, is this the only way we could do it? So for that, I have another interesting experiment. So here, I will just share my screen. Okay, so now here, so earlier experiment, we took different metals, right? Now we have just one metal. We have copper. Okay, we have just copper here. And what I'm going to do is, I have different, okay. So I have different concentrations of copper sulfate solution. So I have with me 1 molar of CuSO4. Then I have 0.1 molar. Okay. These are both same, I think.
0.02. This is 0.02.
Then I have 0.01. I have 0.001 molar. Okay. So I have a copper sulfate solution in different concentrations. And now we will see what would happen. So we have just one metal. And do you think anything would happen in this? A raise of hands if you think there will be, let's say if I check the potential difference with the multimeter, will it show any difference? While you do that, I will just do this. If we can, yeah, I will just label it here, 1 molar, 0.1, 0.01, 0.0. Okay. Now I have some 1 molar. Sorry, if you see, it's very blue in color, right? And now I'm taking some 0.12 molar, which you see is a little bit lighter in color. And I will just put it here. And I have 0.01 molar. And lastly, I have some 0.001. Okay. Okay. And lastly, I have some KMNO3 in the between. Now, I had asked you to think about what KNO3 is doing here. Okay. Let me know if you have the answers. Meanwhile, I will just check this. So I have 1 molar and 0.1 molar. Okay. I don't see much difference. Maybe I will have to reduce. So can anyone see? It is like, this is in milliwatt. So it's like 3. If I go to 0.01, I am seeing it's 15. And if I'm going to 0.001, I'm seeing it is 33. So as you go on decreasing the concentration, there is a difference in the concentration gradient, right? So you have 1 molar and then you go on decreasing and you find these values are the most difference is where you see this 1 molar and 0.001 molar. So again, here what is happening, what is driving the EMF, the electromotive force, is the concentration gradient between these two solutions. So one is where, so let's say here you have more Cu2 plus ions, right? CuSO4, Cu2 plus ions. Here you have less of it, Cu2 plus ions. So what would happen is where there is more Cu2 plus ions, there is a more tendency of it to accept electrons and this to donate. So electrons would generate here and then flow to here where there are more Cu2 plus ions to gain. So we saw that there is, if there is a difference in the concentration gradient, still there is a generation of voltage or electricity, which is very less in millivolts. Okay, so now as we are seeing, so I have one mini setup of a Daniel cell. Have you heard about Daniel cell? Probably. So I will just show a mini setup what we have tried to make. So we have here solutions basically of CuSO4, ZnSO4, CuSO4, ZnSO4, CuSO4 and ZnSO4. So we have a copper and a zinc salt solution. What we did in the electrochemical series, we took all these different metals, right? And we checked its voltage. So we are making a battery out of it. So what we would do, what metal we would put in the copper sulfate solution? Would it be copper or zinc?
Copper.
Yeah, copper. Okay. So we're going to put one copper plate here, and then zinc. So this is a zinc plate and this is a copper plate. So I'm going to put these two here. So again, a zinc and copper. And last, zinc. Okay. So now we have connected this in series. ठीक है. अब हमने connect तो किया है. Now will the LED glow? What do you think? Oh. Is it glowing? No. So it should work, right? Because we saw there is some potential which is being generated last time in the electrochemical cell. So why is it not glowing? So here the role I asked you, right? Why we are adding KNO3 in the center of the electrochemical cell. So why are we doing it? Anyone? Anyone remember anything about salt bridge? Yeah, any trying to recall anything?
Sir, maintain neutrality of cell.
Maintain neutrality of cell, right? So क्या हो रहा है? एक जगह पे there is zinc and copper, and we saw from the electrochemical series which can donate its electrons more readily out of these two. Zinc, right? So you see zinc plus 2 electrons, whereas here in CuSO4 you see that there is Cu2 plus, and it is the one which is accepting these electrons, and you get this. So what is happening here in zinc sulfate is you have a lot of positive ions, and here you see there is less of positive ions, and you have more of a copper. So you have less of these positive ions, right? So you need to maintain the electrical neutrality of this, and that's why we are adding KNO3, which is K plus NO3 minus. So where will K plus go? To which? ZnSO4 or CuSO4? Here, right? Because there is less of positive charge here. And NO3 minus would go here because there is more of Zn2 plus. So that is, it is maintaining this electrical neutrality. So what we're going to do is, I have some strips of just paper which is dipped in KNO3. And what I'm going to do is I'm connecting these two. ठीक है, ये डाला एक. नेक्स्ट डालते हैं such that it is dipped. It is not dipped properly. Just making sure. And then another salt bridge here between these two. Okay. Now, will the LED glow?
Yes, sir.
Yeah. Okay, let's see. Let's see. जल रहा है क्या? Yeah. You see? Okay. Yeah, I think yeah, everyone can see. Okay, okay. We can switch on the lights. And if we see probably the difference, so let me put this here and then put this here. So I am seeing a potential of 2.56. So I have connected 3 cells in series and I am generating 2.5 voltage. Okay. So we saw through these 3 experiments how we are making these 3 different batteries. Now I think Justy, do we have some more time? We can show that.
Maybe it can be concluded in 5 minutes, Trisha.
Okay, okay, fine,
Yeah.
fine. So I will just try to conclude this. So there is one exciting demonstration which we have. So I think my colleague Nisha ji will show. So we saw about the electrochemical series, right? The reactivity. So I will spotlight. Okay, I have spotlighted this. So what Nisha ji is going to do is, so we call this experiment dancing flame, and we have some HCl in this. We have some hydrochloric acid, 1 molar, and we're going to add some copper sulfate. Not copper sulfate, is it? It's copper chloride, right? Yeah. Eco, alright. So we have mixed some copper chloride in HCl. So there is copper salt, right? It's a copper salt. And then you have some aluminum foil. Now, if we can recall from the series, which is higher up, aluminum or copper? Yes? Aluminum or copper? We saw, no? Yeah, aluminum. Yeah. So, so we have Nisha ji with us, and what she's going to do is she's going to drop this aluminum foil into the copper chloride. And I want you to see what is happening, and then from your observations, what reactions could be happening here. Okay. So she just pushes this in here. Okay, you see something? Yeah, what's happening? What are you? Oh, can you observe? Oh, okay. Can you see something? So she is trying to bring a flame to this. Nisha ji, if you can shake the flask once, and then. So you see some gas which is generating. Hydrogen, and then some green flame. If you can do it once again, and then. ज़्यादा zoom मत करो उसको. Yeah. So we could also hear some pop noise, which is hydrogen, and if you can now zoom to the flask, inside the flask. So you see that you don't see the aluminum foil anymore. You see some. If you can, yeah, if you can. Acha, some technical error. Okay, anyways, so we saw this very interesting experiment, and what is happening here? Can anyone tell? Okay, I will just quickly go through it. So what is happening is aluminum is reacting with copper chloride, and it is forming AlCl3 plus copper, and it's also reacting with HCl, and it's making hydrogen gas. So aluminum is very reactive, but interesting thing is, okay, they have. If you can. Acha, they're trying. I think they had a loss of connection earlier. Yeah, I think mostly now, I think all the, yeah, if you can see, right, there is some green flame which is coming. Okay. So what is happening is, yeah. If you can just zoom it to the switch on the light, and then I just want them to see what is inside. Okay, you see some bubbling, and then you don't see any aluminum foil now. I think if you see, yeah, if you see, there is some brownish thing. So what is it? It is the copper. It is a copper metal. So there is a displacement reaction which has happened. So aluminum has reacted with copper chloride, and aluminium chloride and copper has formed. And with the HCl, aluminium has reacted and it has formed hydrogen gas. So this is a combination of these two reactions, which you could see when you bring a flame near it. You see a very nice green flame, which like a kind of a bit dances around. Great. Okay. So I think this would be a good point to end, but I will just quickly show you certain things, probably 5 minutes. Okay, I had a few things, but maybe we can do it later. Nishati, can we have the? Yeah. Yeah. So finally, I will just conclude with this very interesting experiment, which we call it electrolytic writing, where we write without any ink. Okay. So have you ever tried doing that? Like without any ink, if you can write. Okay. So what I have is, I have a filter paper and I've just taken this foil, and what I'm going to do is, I have a salt solution which I'm going to just drop on this, and one another interesting thing which I think you can identify based on what color we get. So if I can have a battery. Well, yes. So I have a battery and I have something like this. So instead of a pen, ink pen, I have this, where I have a metal copper metal, and I connect it to the two ends. So one with the pen and one with this. And let's see if we can write anything. Okay. So can anyone tell their name quickly? I want to write their name here very quickly. Anyone? Yes? No names?
Rahul.
Sorry? Okay. Okay, for some reason. Okay, there is some some problem with this. It doesn't seem to be working. Let me add some more electrolyte and some salt.
Change it.
Yeah, something wrong.
Change it.
Do we have another battery? It's not working. Maybe some problem with the battery.
Hi, Srisha. Sorry to
Yeah.
interrupt.
Yeah.
I
Sure.
would suggest, this experiment, if it could be recorded on video and shared
Yeah.
in the WhatsApp group that we have.
Sure.
Yeah, because
Definitely.
we are running out of time.
Sure. Okay.
Yeah.
Okay. Fine.
Yeah.
So
Thanks.
so I will just conclude the session. So this was something where we were trying to do some electrolysis, but I will share that in the video, and then you can also try it out. Very simple to do, where you can write without using any ink. So we saw a few different things. We made certain kind of batteries, electrochemical cells. We explored electrochemical cells. We explored Daniel cell, and the voltaic pile, which is the first battery which was made. Okay, great. So I think if there are any questions, please let us know in the group, and we will also be sharing some activities which I think you could do, which I think Justy will brief on. I hope it was an okay and interesting session for all of you, and I would like everyone who are watching this later on YouTube to try this, make your own battery, and share the videos or the pictures on the group.
Thank you so much, Srisha. I think the students are awaiting the video. We will see that whatever we have missed, I think we will see that in the WhatsApp group in which the video will be shared. Thank you so much, IIT Gandhinagar team, and to Navodaya Vidyalaya Samiti for great support for this Sparkle series session. We will meet very soon with our last session of this Sparkle series, and the information will be given to you soon about the session. Till then, as I always say, keep being curious, keep experimenting, and fall in love with STEM. Yeah. All right. Thank you. Bye-bye.
Bye.